So I will start with this question. Okay. So until now, we have to learn from our mistakes. So this is the question. Could you read this question and solve this question for me, Habiba?
Okay. It says after breaking a leg, a girl was given crutches. The free body diagram for the girl when standing with the crutches is shown. Half of the girl's weight W is supported by the reaction force R of the ground on her leg. Half of her weight is supported by F1 and F2. The forces of the crutches on her body, F1 and F2, are at the same angle to the vertical. Show that the magnitudes of F1 and F2 are equal.
So what do you think about the first equation? Is this correct or incorrect?
I don't think it's correct.
You don't think?
No.
Why it is not correct? What
Weight
is the
is
missing in this?
the weight is supposed to be equal to the reaction force and the vertical component of the two forces,
Yes,
not just.
perfect. Perfect. Yes. So this is incorrect because, as you know, force up equal force down in case of what? Equilibrium. But F1 and F2 not upward. It has an angle with the vertical. So when I say F up, I means vertical upward, and F down equal vertical downward. So it is not accepted like this. But as Habiba said, you can write weight equal R plus F1 horizontal force plus F2 horizontal force. Sorry, vertical. So we can write like this, okay, if you want. But I think he said show that the magnitude of F1 and F2 are equal. So what do you think, Habiba? Is this answer is correct? Yeah, if we complete this answer, we will gain the correct answer or no?
Um, uh, no.
Okay, so now what is the new technique? What should you write?
We are supposed to talk about the horizontal forces.
Yes, because the girl is stationary. Okay, so we can talk about what? F horizontal equal 0. Of course, I'm talking about resultant. So F right equal F left. So now we will talk about what? The horizontal component of F1, horizontal component, and the horizontal component of F2 must be equal because the girl is in equilibrium. So we can write horizontal component first. Horizontal component of F equal F cosine or sine.
Sine.
It will be sine theta because the angle in the question is with vertical. So angle with vertical, so the horizontal will take what? Sine theta. After that, we can write so F1 sine theta equal F2 sine theta. As theta is the same, so F1 equal F2. This is the correct answer. Do you understand, Mirola?
Yes.
Okay, so now I can say what? The question here, he said F2 cosine theta and W equal R plus 2F. So all of this is incorrect. Incorrect. So first we correct this mistake. But when we correct it, we can't use this in what? In this part of the question. Okay, now, Mirola, what do you think about this part? Calculate the magnitude of F1. So again, this is the question. So you can take a photo if you want. Okay, this is the question. This is the girl. So we have weight and F1 and F2, and we have normal reaction force. Okay, so this is the question he asked. He said what? We have force but upward. It's force. Okay, so now Mirula, can you solve this part? The second part. He said find F1 and he gave us weight and angle of F1 is 10. It means this angle is 10 and also this angle is 10. So can you find F1?
Is it gonna be W, negative W?
So we can say what? Resultant force equals 0,
Oh,
right?
right,
Which means F upward equal F downward, right?
right.
So now what is the force downward? Just weight.
Wait.
So now weight will be written here. What about the forces upward?
F1 and F2 and the
Yes,
normal
so we
reaction.
have R, the reaction force, this force, okay, and we have the vertical component of F1 and F2, right?
Right,
So we can write also vertical component of F equal F cosine theta, okay?
okay,
So now he said R equal half W. In this question, he said what? R equal half W. Okay, R equal half the weight, right?
right.
So now, if weight equals 650, so R equal what? 325, right?
Right.
Now we can write what? F1, can you complete?
Yeah, F1 cosine 10.
Theta plus F2
F1, F2, sorry, cosine
cosine
theta.
theta plus R
R
equal W,
equals, right,
right? And we said
right,
before F1 equal F2, right?
right.
So now how many F cosine theta we have now?
2,
2F cosine theta plus 325 equals 650, right?
right.
So now if we need to find F, it will be 650 minus
325.
over 2 cosine 10, right?
Right.
So F equal what?
165.
Newton. So now this is the answer for this part. The next part, Habiba said what? B.
The diagram below shows the forces acting on one of the crutches. The crutch is at an angle theta to the vertical. The weight of the crutch has been ignored. There is a maximum frictional force that the ground can exert on the crutch. Explain what will happen if the girl moves the base of the crutch too far from her foot.
What it means the girl, it will move, it will increase the angle, right? Like this, right?
Yes.
Okay, so now what do you think? What is the correct answer?
Um, when the girl moves the crutch too far, the angle will increase, and the force has like a horizontal and vertical component. When the angle increases, the horizontal component will increase. and then it will be like more than the frictional force, so she may slide.
Yes, perfect. Because what? Because if we want to talk about what happened if the angle increase, we need to take what? The horizontal component only, because the girl is what? In equilibrium. While standing, she is in equilibrium. Okay? Horizontally in equilibrium. So now we can write as theta increase. What happened to sine theta? Increase also, right? Horizontal component of the force from what? The crutch, F sine theta. Okay? So now as theta increase, what happened? Horizontal component increase. Right? Which make what? Okay. Do you understand, Mirula?
Yes.
Okay, now about this question. What do you think, Mirula? I'm talking about II.
Is it gravitational potential energy?
He said state an equation for the energy
Um,
transferred to the sample. So what is the energy
MGH.
transferred with an equation?
Um, MGH.
mgh. Which h? This one or this one?
Um,
In fact, it will be change in gravitational
Negative.
potential energy. This is the change. This is the energy transferred, right? Which
Right.
converted to kinetic energy, in fact. But you have to write the equation describing that energy transferred. It will be mg h minus h. You can
Okay.
add equal change in kinetic energy, but it's important to write what? mg h minus h, because the change in gravitation is converted to what? Kinetic energy. And he said state an equation for the energy transferred to the sample. Okay?
Okay.
Okay, now let's move to the next. Now it's your turn, Habiba. This question, this part.
Upthrust force can't increase.
Yes, because upthrust force equal rho Vg. So there is no change. There is no change in the density and the volume. The change in what? In speed. Okay. So when it reached to constant velocity. So what do you think? What is the correct answer?
It's supposed to be drag increases until the weight is equal to upthrust and drag.
Yes, perfect. So now these 2 marks, we will write what? Explain why after few seconds the system will be at a constant velocity. We can write F net equals 0 as weight equal U plus F drag. Okay, so at terminal velocity, you can start with the speed increase, terminal velocity increase as speed increase. What happened? Drag force increase until until what? F net equals 0. So W equal U plus FD. Now it reaches to its terminal velocity. So it will fall, it will move with terminal velocity. Okay, now let's move to the next. So what is the first mistake, Merula? 1, 2, 3, 4. What do you think? So is 1 is correct or not correct?
Not correct.
Not correct. Explain why. Because GPE is energy while F net is a force. Is energy equal force?
No.
So now this is incorrect. Okay. So this is why it must be wrong. All of this is wrong. Okay. So now, what is the correct answer, Mirula? What do you think? He said the gravitational field strength of Earth show that this results in an acceleration of free fall. So now, what is the force exerted on the object while falling?
It's gonna be F net equals MA,
So
which
now
is
we can write F
acceleration.
net equal mass multiply acceleration. What after this? What is the
W
force downward?
equals
It will be
mg.
weight, right?
Right.
Equal mass multiply acceleration. Weight equal mg equal mass multiply acceleration. We can cancel out what? Mass.
Mass.
So now acceleration equal g equal 9.81. Easy question. We take it before, right?
Right.
So all of this, he said since h equal 1 meter because unit is meter. All of this is incorrect. From where this student get this answer, I don't know. Okay. So now let's move to the next. So Habiba, what do you think? What about this answer? Is this answer is correct or incorrect?
Um, I'm not sure what.
What do you think? Is this correct or incorrect?
I don't see any mistakes, but I don't know why it's not
Right,
correct.
you are right. Okay, but I think he forgot to write what? He said accelerate away from the ground. He forgot to
Yeah.
write the direction of force. He should write
Oh,
what? The gas exerts an force, a force, for example. Okay, because he didn't ask in this question to mention 2 Newton third law, but it's okay. Okay, the rocket, instead of rocket exerts a force on the gas, he is talking about the spacecraft. Okay, so now he can write what? The rocket exerts a force on the gas. Okay, the gas exerts an equal force and opposite direction. What is the direction? Upward. So you can write the gas exerts an upward force on the spacecraft, right? Right? Okay,
yes.
so there is a upward resultant force. Okay, cause the acceleration upward. Okay, so now we explain how this enables the spacecraft to accelerate away from the ground. It accelerates always. If you write why we have acceleration, because we have a resultant force. Okay, so be careful while writing because what he said. on which results in a resultant force upward. Okay, so resultant force upward is correct. So the student now can gain what? The full mark. But it will be better to write like this. Okay. What about this part, Mirula?
Um, uh, F equals MA, and then the mass is 81 kilograms
So this
of the
equation
crew
is
member.
correct now.
Yeah.
So the student can gain 1 mark. Okay. And what is F
Um,
net, Mirula? What is F net equal? Is
Mass
F net
times
equal
acceleration.
3,700, or it will equal 3,700 minus,
Minus weight.
yes, so it will be 3,700 minus 81 multiply 9.81. So now if we want to find the acceleration, it will be 3,700 minus 81 multiply 9.81 over 9.81. So the student in this question forget to what? To find the resultant force, because this question has 4 marks. If he write like this, if this will be correct if the question about 2 marks only. Okay, so this is a mistake in this part.
Sir,
Let's talk about question D. Habiba.
sir, I have a quick question about the last one.
Yes,
Why is the apparent weight larger than the actual, like the calculated?
the apparent weight.
Yeah.
It is not real weight. Because what? Because the apparent weight due to what? Due to the thrust force. It pushing the rocket or the spacecraft upward. So now we have force up and the weight is down. Okay. So when he said in the question, as the spacecraft take off, the apparent weight of a crew member is 3700 Newton. So this he mentioned to what? The upward force, the thrust force from the rocket due to pushing the gas downward. Okay.
Okay, sir.
Now, Habiba, what do you think about D? Is this correct or incorrect?
It's incorrect.
Why?
Um,
Do you know the student understands the question and he is very good to to answer this, and he thinks this is right while solving. He thinks this is an easy question and his answer is correct. But in fact, he has a mistake. The first mistake, what? What do you think?
it's the surface area,
Yes, we have to replace surface area with what?
the cross sectional area.
Yes, cross section area. Because if we talk about surface area, we are talking about 3D object, like volume, for example. Okay. What else? He said when they are open, air resistance increase quickly. So now we have air resistance increase. This is right. Okay. Right, Habiba? Or this is
Yes.
wrong? This is
No, it's
right.
correct.
Yes. What about this? Do you understand anything from this?
Not really.
Because what? Because he has a sign like this. Okay, it didn't appear in what? It doesn't appear in the scanning. Okay, so I prefer to write the word air resistance greater than weight. Okay, okay, what do you think? Is this correct or incorrect, Habiba?
I think so.
Okay, but I prefer, because if you want the parachute to reduce the speed, you are talking about a deceleration, right? So,
Yes.
because he said when the cross section area increased, air resistance increase, so I prefer to what? Now, for example, this is the first and this is the second. I prefer to write number three is resultant force upward. Because if resultant force, because what? Because air resistance greater than weight. Okay, so capsule decelerate until it reaches slow final velocity or, or terminal velocity and can land safely. So the resultant force upward, so the capsule decelerate. So what do you think now, Habiba? So I think the mistake here is what? Is he didn't mention two greater than, he put the sign and the sign is not clear. Okay, so maybe the examiner can't understand what the students mean. This is why you don't use symbols like this. Okay, if you want to use symbol, you can write, for example, air resistance greater than weight, for example, like this. Don't write air resistance greater than, then complete weight like this. It will be not clear. Okay, so do you understand, Habiba?
Yes.
I show these mistakes because I don't want from all of you to do the same mistake in the test. Okay, now let's continue. So what do you think, Mirola? What is the missing in this part? The student again 2 over 3.
Uh, not sure.
Okay.
I don't
So he
know.
didn't mention to what? What do you think, Habiba? He just need to add what? As distance, horizontal distance, traveled is the same. He have to write what? U horizontal A equal U horizontal B. After that, U horizontal A equal UA cosine theta and U horizontal B equal UB cosine theta. After that, he can add all of this. Okay? Because sometimes the examiner follow the mark scheme only. So if I correct this question, I will give the student 3 over 3. But sometimes the examiner follows the what? The mark scheme. So you have to show all of this. He should show that. So you have to start from the beginning. They moved the same horizontal distance. So it means what? Because horizontal distance equal v multiply time, and they are moving in the same time. So UAH equal UBH. Okay, so step by step, don't move quickly. Okay, now, Habiba, how can we solve this question?
We can talk about the vertical and the horizontal component.
Okay,
It says, wait for the pass of the trip. UA is greater than UB because UA is launched at a greater angle, so the vertical velocity would be greater. So
yes.
it would reach like a higher maximum height, and the horizontal velocity would be less.
I prefer to start from here. As you said, the angle of UA greater than 45, right?
Yes,
So cosine, cosine or sine, because we talked about we talk about cosine. So cosine theta will be less than cosine 45. Is this correct or incorrect?
it's correct.
Correct. Okay. So now, as we said before, we said UA, this is UA equal 0.707 UB over what? Cosine theta. And as we said, cosine theta is less than what? 0.707, right? So UA will be greater than UB because 0.707 over cosine theta will be greater than 1. And you can, of course, you can make an example for you to be sure this is correct. You can find, right, for example, we said the angle is 45. What about cosine 50? What is the answer of cosine 50? Cosine 50 equals 0.64, for example. So now the answer is what? Greater than 1. This is why UA will be greater than UB. Do you understand, Habiba?
Yes,
Do you understand, Mirola?
Not really.
Okay. So again, Mirola, he said explain why for the pass of the two projectiles to be as shown, UA is greater than UB. Why UA greater than UB? Why is the initial velocity of the projectile when the angle is greater? This angle is 45 for UB. What about the angle of UA greater than 45? Okay, Mirola?
Okay.
So any angle greater than 45, cosine of this angle will be less than cosine 45. And you can make an example. Write any angle except 45. You will find what? Greater than, طبعا. Greater than 45. So the maximum will be what? Cosine 45. Okay? Any angle greater than 45, the cosine will be less. Okay? Okay, Mirola?
Okay.
And we said firstly, what? We said this part, okay? Then this part, right? And it is written in
Right.
the question, okay? So now UA equal from the question 0.707 UB over cosine theta. Do you know what's meant by 0.707? In fact, this is cosine 45, Mirula. Okay?
Okay.
And we said this theta is greater than what? Greater than
45.
45. So this cosine will be less than this number. What it means? It means this ratio will be greater than 1. Okay?
Okay.
So
Yeah.
now it means UA will be greater than UB. Okay? Do you understand?
Yeah. Understood.
Okay. This is repeated. Now let's move to this question. So, Habiba, what do you think? How can we draw this question? We have UA and UB. So which one is greater? UA, of course, we will draw for vertical. He said on the axis, blue sketch labeled the graph for the vertical component of velocity. So which one is greater? The vertical
Uh,
component of A or B?
of A.
Of A. So it means we will start with a greater for UA, greater than UB. Okay? Okay, now, how can we complete this diagram? For UB, the projectile move the total range, the distance. So what it means? It means at time it moved to the maximum height, and at maximum height v vertical equal what? 0. Is this correct, Mirola?
Yes.
Because as we moving upward like this, as we moving up, for example, we start with u horizontal and u vertical. While the projectile moving, v horizontal is the same. There is no change. But what happened to the vertical? Decrease. Decrease until become what? 0 at maximum height. After that, it will increase, but in opposite direction again. This is why if we want to draw the graph for UB, it will be like this. So at T half, at half time, now V vertical equals 0. But as you see, for UA at the same distance, we still have V vertical. It doesn't reach to 0. It will be so close from 0. This is why we will draw like this. The second one will be like this. So close from 0. So do you understand, Mirula, my drawing?
Yes. But I have a question.
Yes.
What if it asks for the horizontal component? Would it be
The
a
horizontal
horizontal?
component, the horizontal component, okay, is constant. It doesn't change in fact. But what? The horizontal component of B, okay, and A is equal. And we said this in this part. The horizontal component is the same. Okay? So now we can say if we ask it to draw the horizontal component, it will be like this. Both will be like this. There is no change. Okay, Mirula?
Okay. Thank you.
Because in horizontal component there is no force as we ignore a resistance. Do you understand, Habiba?
Yes.
Okay. Now let's move to this question, Mirula. What do you think? How can we solve this question?
Do we write the equation?
Okay, what is the equation you want to write?
Um, up thrust.
Our thrust force is negligible. We can ignore it.
Oh, so drag force
Okay, drag force
and weight.
and weight. What's the relationship between them?
They're equal.
Why? You have to start with at what, Mirola? At terminal velocity. F net equals 0, right?
Right.
What it means? Weight equals
Equals
drag force, right?
drag force. Right.
Okay, what else? Weight is because we want to find a relationship between, he said moving quickly, so we need to find a relationship between terminal velocity and the size. Size, in fact, is radius or diameter, right? Because it's
Right.
a droplet, it's a sphere, okay? So we
Okay.
can replace W with what? 4 over 3,
R cubed pi r cubed.
yes, multiply rho multiply G, right?
Right.
Equals 6 pi eta R
R
V,
cubed.
right?
Right.
Now, what is the relation? We can cancel out R with cube. So now we can write 4 over 3 pi R squared rho
Squared.
G equals 6 pi eta V. Now, what is the relationship between V and R squared?
Directly.
So we have to write it. Velocity is directly proportional to the radius square, right?
Right.
So
But would it make a difference if I just wrote radius?
you said radius only because
Yeah.
from this equation, the relationship between V and you can write what as radius increase, terminal velocity becomes greater or increase. Okay.
Okay.
Or you can write the droplet with a greater radius, it has a greater terminal velocity. Okay.
Okay.
So greater terminal velocity. Okay. Now let's continue. Now it's your turn, Habiba. What's
Do
energy
I?
transfer, Habiba? Because they said your answer should be in term of energy transfer. So what's the energy transfer here?
In the beginning,
Yes,
uh, when the person is running, they had kinetic energy,
perfect. Two,
and then it converts to elastic when the pole bends.
elastic potential energy. Yes, two,
Gravitational potential energy.
gravitational potential energy plus kinetic energy. We
Yeah.
can ignore kinetic energy, no problem. Okay. Okay. So now can you solve the question? Explain how using the pole enable the athlete to reach the greater height.
Okay. So okay. In the beginning, they had kinetic energy, which is converted into elastic when the pole bends, and then when they're jumping, the elastic is converted into gravitational potential, and there will be additional gravitational potential energy from the pole, which helps the
What is
person jump.
additional gravitational potential? Again, sorry, the last part, repeat it, please, Habib.
The pole has elastic energy,
Yes,
which is converted into gravitational potential, and that like gives the person
perfect. Yeah,
additional
yes, yes. So,
because
so you
the
mean,
gravitation.
okay, so
Yeah,
by the end, we need to write what? He said explain how using the pole enable that you can write the elastic potential energy stored in the pole greater than the elastic potential energy stored in what?
the person.
The person. This is why it will give a greater gravitational potential energy.
Okay.
Okay, do you understand the Mirula?
Yes.
Okay. Now let's continue. Mirula, what do you think? Can you solve this part?
Um, can I use v squared equals u squared plus as 2as?
V squared equal U squared plus 2AS. You won't use
Is
this?
that yeah?
I can't accept this, in fact.
Uh,
Do you know why?
I'm not sure.
Okay, what do you think, Habiba? Can we use this equation?
I'm not sure about that. I don't think so, but I don't know
Okay,
why.
I will give you a chance, Mirola, to complete. Okay, complete, Mirola.
Okay. 1.1 squared.
Mirola, will you do in the acceleration?
I'm gonna use 9.81.
9.81. I don't think so because the person is not moving upward like this. He has horizontal and vertical. Okay,
Okay.
so in terms of energy transfer, Mirula, we can write what? Do you know the energy is conserved or not? Do you know
No.
the energy is conserved, right?
Right.
So we can write what? What is the type of energy we start?
Kinetic.
What about gravitational potential energy?
0.
Zero. What about at this point? We
Highest.
have we have both gravitational plus kinetic, right?
Right.
So now we can start with what? The change, we can write kinetic energy plus gravitational potential energy for initial equal kinetic energy plus gravitational potential energy final, right?
Right.
And because we start with there is no gravitational potential energy, we can cancel out this part, right?
Right.
So he said calculate the maximum possible change in height. So now we can write what? The height is here. So the change in gravitational potential energy is equal what? The change in kinetic energy because we can move the final to this term, right?
Right.
Initial minus Ke final. Do you understand, Habiba?
Yes.
Mirola, do you understand?
Yeah, but where do we find the mass?
Mg delta H Mirola equal half mass V squared minus half mass V squared, right, Mirola?
Right.
We can cancel out what, Mirola?
The mass.
Yes, this is
Okay.
why we have to write like this.
Okay.
Okay, let's continue. Okay, delta H equal, okay, half multiply, what is the final, what is the initial, sorry, initial minus final. What is the initial velocity? 9.4
9.4
squared, okay, minus half multiply 1.1 squared. All of this divided by 9.81. This will give you the maximum change in height in meter. Do you understand, Mirula?
Yes.
Okay. Now we'll start a new lesson. This lesson is called a Hooke's law, and I think you take Hooke's law in IG also, but we will increase in this part a new thing. So first, what is Hooke's law? Hooke's law is a relationship between force and extension. So now, what do you think? If we have a spring like this at the left or at the right, okay? So now, what if we hang a mass like this to this spring? What happened to the length of the spring? What happened? So before, so again, from the beginning. So this is the natural length. This is the original length. So Habiba, what happened when we hang a mass on the spring? What happened to the length?
The length increases.
The length increase. The difference between the final length or stretched length and the original length is called extension. Extension. Okay, so now we can measure this extension using a ruler. So this extension, for example, is 24. Okay, now what if we increase the force by adding a greater mass? What happened to the extension, Mirula?
increase.
Increase. Okay, now what is the force affects the spring? It's the weight of the mass, right? And as the force increase, what happened to the extension? Also increase, right? So now what is the relationship between the force and the extension, Habiba?
They are directly proportional to each
We
other.
call, yes, we call this what? We call this Hooke's law. So Hooke's law is a relationship between the force, the applied force or the load, and the extension. The extension is directly proportional to the load or the force. Okay, so as you see, a material obeys Hooke's law if the extension of the material is directly proportional to the applied force or the load up to the limit of proportionality. We have limit of force or limit of proportionality. Okay, and this relationship will be linear relationship. This will be linear relationship until when? Until the limit of proportionality. What after limit of proportionality? The relationship will become no longer straight line. It will be curve. It will be curve until a point called elastic limit. So we start with limit of proportionality, the point at the end of the straight line. After that we have a curve. After that we have elastic limit. Okay, before elastic limit, the object can return to its original shape. Okay, any point before elastic limit, when we release the force, the object will return to its original length. Okay, but after elastic limit, the object will be permanently stretched. So when we release the force after the elastic limit, it will be like this. Okay, we still have extension. Okay, or it will be like this. Sorry, it will be like this. We still have the force will be 0, but we still have extension. So while explaining Hooke's law, you need to know the relationship between force and extension is proportional until limit of proportionality. After limit of proportionality, what happened? There is no directly relationship, but the spring will return to its original shape after releasing the force. Okay? So for any spring, any rubber band, any object, any wire, obey Hooke's law, linear relationship between force and extension. Now what is K? K is a constant. K is a constant and equal if we place force in Newton and extension in meter, and we draw the relationship between force and the extension is directly this spring obey Hooke's law, we can find K. What is K? The spring constant, or it also called stiffness. Stiffness. Okay? So the spring constant is what? Equal force over extension. So the unit of the spring constant will be Newton per meter. So it will be Newton meter -1. Okay? And it can also calculate it by using what? K equal gradient of the line. Habiba, gradient of the line. What if we flip the graph like this? If we place the force here and extension here, what do you think?
I'm not sure. K would still equal F over X, but I don't know what to do with
Yes,
the graph.
yes. K still equal F over X, right? But it will equal 1 over gradient, because now the gradient will be X over F, not F over X. Okay? Okay, Habiba.
Okay.
I will send a new link because I think it will close now. Okay. So now again, what I mean is, if he flip, okay, if he flip, so now we find F in Newton and extension in meter or centimeter. So K still equal force over extension. But now K is not equal gradient, it will be 1 over gradient. Do you know what is the difference now, Habiba?
Yes.
Mirola, do you know what is the difference?
Yes.
Okay. Also, I have a question. Now I want to find the unit the base unit of spring constant. Can you find it, Habiba?
We can write Newton meter to the power of -1 as kg meter per second to the power of -2 times m to the power of -1. And then the 2m will cancel out, so it's just kg s to the power of -2.
Perfect. This is perfect. Correct. Do you understand, Mirula?
Yes.
Okay, let's continue. So now, what if I increase the stiffness or K? What if I increase K? So now, as you see, we have in this example, this is the stiffness, and I will increase K in the other side. It will be large. Okay. So do you see what is the difference between spring 1 and spring 2, Habiba? Is this clear?
Yes.
Okay, now I will add 100 gram in both. So now, what is the difference between the extension in both? As spring constant increase, what happened for same force? Which one has a greater extension? Mirula, which one has a greater extension? The
One.
greater spring constant or the lower?
The lower.
The lower, yes. So as we increase the spring constant, for the same force, the extension will decrease. Okay? Okay. Now I have a question. What happened to the spring constant if I increase force? If I asked you to draw the relationship between K, okay, Habiba, and force. How can we draw a relationship between K and force for same spring?
They're directly proportional. So
What
you draw
about you,
like
Mirula? Do you agree or disagree? Habiba said
Um.
directly proportional. What do
Do
you
you
think?
agree?
Do you agree?
Yes.
But I disagree. Do you know why, Habiba?
no.
Because for same spring, it will be constant. We call it spring constant. So, for example, this is the spring constant, okay? What will happen if I add greater mass? Is the spring constant a change?
No.
Okay, so you have to know what the spring constant, it called spring constant because it's constant. If I want to change it, I need to change the spring. Okay? Okay, so this is the first part. So spring constant, you can find the constant from the gradient of the line. So the only change will be between what? Force and extension. The spring is constant. Okay? Okay. After that, we will move to this part. So now is a property of material being stretched and measure the stiffness of material. So constant is what? A property of the material. It cannot be changed except if we change, for example, the number of turns of the spring, the distance between the length of the spring like this. But it's a property of the material being stretched and measure the stiffness of material. The larger the spring constant, the stiffer. So large constant means stiffer material. Okay? Hooke's law apply to both extension or compressions. Okay? And also you have to know that now I have this spring, okay? What is the extension now, Habiba? Applied force equals 0, and the spring constant is 500 Newton per meter. So what is the extension now?
It's 0.
Yes, there is no extension. Okay, now I will exert a force on the spring to stretch it. So now my force is 50. Okay, now Mirola, what is the resultant force equal? Mirola, what is the resultant force equal?
50?
50. Habiba, what is the resultant force equal? Is this 50? Do you agree?
No, but I'm not sure.
If no, what is the resultant force equal?
I'm not sure.
Okay, now there is a hidden force which is called what? Because if there is a force exerted on the spring will exert a force on the person, for example. So we have two forces. The spring is in equilibrium, so the force of attraction or the force exerted from the person to the spring, okay, there is a force from the spring to return to its original shape. We call this elastic force. Elastic force. So elastic force equals applied force, as you see. Okay, and as we increase the applied force, elastic force increase. As we decrease the applied force, elastic force decrease. Okay, so elastic force is the force which which return or which return the spring to its original shape. Okay, and it's also, you have to know what, always the force of the spring in opposite direction of the displacement. So as you know, the green arrow is displacement to right, but the force from the spring is to left. Okay, so now if I asked you, for example, Habiba, if I draw like this, and I asked you to draw in this the force body diagram for this what spring, what do you think? How many forces?
2.
Two or three? There is force W, right?
Yes.
What is the second force?
The elastic force upwards.
What else? Tangent force,
Yeah.
right?
Yeah.
Because the spring itself, without any loads, affected by tangent force, equals the weight of the spring itself, right?
Yes.
Okay? Okay. So, what else? So now we understand Hooke's law apply the both extension and compression. What about compression? Now we can compress the spring like this. As you see, the blue arrow, okay, explain the direction of the force from the spring. to return to its original shape. The right arrow, the blue arrow, represent the direction of force from the spring, because the spring is compressed and it wants to return to its original shape. Okay, do you understand, Habiba?
Yes.
Do you understand, Mirula?
Yes.
Okay. Now next, the extension of an object determined by how much it has increased in length. The compression of the object with it compressed, the length decreased. Okay, until now we draw the first graph, the graph between what? Extension and force, right? And as you see, to describe this relationship, the line must be straight and start from the origin point. If you want to draw relationship between force and extension for any spring, obey Hooke's law, it must start from the origin point 0, 0, and must be straight. Okay, what if I want to draw the relationship between the force and the length of the spring? What do you think? For object, for example, spring, obey Hooke's law. What do you think, Habiba? How can I draw this?
It's also a straight line, but it doesn't start from the origin.
Perfect. It starts from what? What can we call this point, Habiba?
I'm not sure.
Mirula,
The
Mirula, what can we call this point?
When it starts to extend.
The original length.
Yeah.
The original length, right? Because we can't start from zero because there is no length of spring equals zero. So for example, when we start without any loads, we have the length of the spring, which equal, for example, 45. So if I want to start drawing relationship between force and the length, it will start, for example, from 45 centimeters. Okay. After that, as you add force, as you add loads, what's happened to the length? Increase. If you want to find, for example, the extension at this force, you have to subtract the stretched length minus original length. This will be the extension. So we can add this equation, extension equal L minus LO. L minus LO. Stretched length minus original length. So extension equals stretched length minus original length. Okay? And we said also K equal F over X, right? So we can write K equal, we can replace F by mg because the force is equal mass added multiply g, and we can replace x with L minus LO. So all of this can be used, okay, to find the spring constant. Okay, so now we have these four graphs. We have this graph and we have this graph. Force extension, force extension. So both will be what? Straight line from the origin point. We have also force and length, force and length. So it will be also straight line, but start from what? Original length. Do you understand, Habiba?
Yes.
All of this obey Hooke's law because it's straight line. If he asked you to explain why in this case, in 2, for example, and 3, why it obey Hooke's law, okay, although it doesn't start from the origin point, we will say, well, what? Because it is not extension force diagram, it's a length force diagram. And any object on a spring in a rubber band has an initial length. This is why it can't start from the origin point. Do you understand, Habiba?
Yes.
Mirula, do you understand?
Yes.
Sometimes he will ask you explain why it doesn't start from the origin point, because if we have length with force, it must start from the original length. Okay? Okay. So now, this is the next part. Force extension graph. The way a material responds to a given force can be shown on a force extension graph. A material may obey Hooke's law up to a point. What can we call this point, Habiba?
Limit of proportionality.
Yes. What after limit of proportionality? Be careful, because until this part, the spring or the object is elastic. What's the meaning of elastic? Elastic region, it means it will return to its original length. It will return to its original shape. Okay? What after the elastic limit? It will be plastic. What's the meaning of plastic region? It will not return to its original shape. It will be permanently stretched. Okay? Okay, Habiba? Okay, Mirola?
Okay.
Okay.
Now, as more force is added, the graph may start to curve slightly. It happened, but after or beyond the limit of proportionality. Okay, so if he asked you to draw a spring, obey Hooke's law, you have to start from the origin point if you have force extension diagram, and also it must be straight line. Now, the Hooke's law region of a force extension graph is a straight line. The spring constant as is a gradient of the line, but with one condition. What is this condition? Force at the vertical and the extension at the horizontal. So now the K equal delta F over delta X equal gradient. Now, what is the key features of the graph? Which graph we are talking? Force and extension. We have 2 points. And also we can talk about the spring constant is the gradient of the line. So we have the limit of proportionality and the elastic limit. So can you read the limit of proportionality, Mirola?
The point beyond which Hooke's law is no longer true when stretching a material, i.e., the extension is no longer proportional to the applied force. The point is identified on the graph where the line starts to curve.
Okay, what about you, Habiba? Can you explain the elastic limit?
The maximum amount the material can be stretched and still return to its original length. above which the material will no longer be elastic. This point is always after the limit of proportionality.
Okay, so you can't draw, you can't replace elastic with limit of proportionality. Limit, after that, elastic limit. Okay? Okay, now I will start with you, Mirula, to solve this example. The question is, calculate the spring constant. Mirula,
The original length is 10.
sorry?
The original length is 10.
Yes, so
Oh,
this is the original length, LO.
uh, we draw a triangle, rise of a run.
So we will draw a triangle like this. Okay,
Um, F1 equals 0, and
you
the
can write
length.
K equal F over delta X, right?
Right.
Or delta F over delta X, and
It's
delta F
1 over
equal
gradient.
also equal gradient. Okay,
1 over gradient, right?
so delta F is what? Equal what?
Um, 0.4.
Yes. What about delta X?
5,
It will be L minus LO, right?
right?
Yes, it will be 15 minus 10 equal 5, but be careful because this is 5 centimeter. Okay,
Okay.
so you need to convert it to meter.
Divided by 100.
Divided by 100 equal 0.05. Now can we find K?
8.
Will be
0.4
0.4. Yes,
over 0.05 equals 8.
equals 8. What is the unit?
Newton over meter.
Yes, Newton meter minus 1. Now it's your turn, Habiba.
Um, well, we could first find the spring constant,
Yes,
which is two over 0.3.
yes.
And that will give you 6.7.
Okay,
And then we can find the extension, which is 6 divided by the spring constant,
yes. So
and
what is
that
the correct answer?
0.9.
So D. Okay, I will
Yeah.
show also another method. Instead of finding K, we can write what is the relationship between force and extension, directly proportional, right? Right?
Yes.
So it means what? F1 over x1 equal F2 over x2, which is equal K because K is constant, right? And also it's the
Yeah.
same thing if you use M1 over x1 equal M2 over x2. Okay, it will make you solve this question faster. So now we have force and extension. Okay, and a force, and we need the new extension. So we can write what? 2 over 0.30 equal 6 over x. Okay, cross multiplication, it will give you the same answer. Do you understand, Habiba?
Yes.
Mirola, do you understand?
Yes.
Okay, so it's so correct. Next, Mirola.
C.
D,
C.
C. What do you think, Habiba? Is this correct or incorrect?
It's correct.
Correct. Okay, let's move to the next, Habiba.
I think it's D.
What about you, Mirola? Agree or disagree?
I'm still thinking.
Sorry?
I'm still thinking.
You still reading?
Yes.
Okay, I'm waiting. So Habiba said it's D.
D.
Okay, correct. Let's move to the next, Mirola. It's talking about energy, and we didn't take the elastic energy yet, so I will skip this question. So now, Mirola, this question, please.
So we draw a triangle.
Yes.
Um. K equals 1 over gradient.
Okay. Because this is a multiple choice, you don't need to write the steps like this. You can find K equal F over
Okay.
extension directly. Okay?
Okay.
Okay.
A.
Habiba, do you agree or not?
No.
Oh.
No. I got D.
You got D. Do you know why, Mirola?
Yeah, I didn't convert.
Yes. Why you have to convert, Mirola? Because he gave you the answer in Newton meter -1. He didn't give you the answer in Newton centimeter. If he gives you the answer with Newton centimeter, you have to convert. You don't need to convert, okay?
Okay.
Okay, now Habiba, it's your turn. This question.
It's C.
C. Habiba said C. Mirola, what about you?
I don't understand the question.
Read the question loudly.
A force is applied to a spring and the spring extends. The new length of the spring is recorded. This procedure is repeated for different applied forces.
Okay,
Which of the above graphs could be obtained from this experiment?
okay. So, which graphs obey Hooke's law?
Oh.
So now we have extension doesn't start from zero. This is incorrect,
Mhm.
right?
and
So Q is correct, right?
yeah, Q.
And
C.
R is
Correct.
correct. So C is the correct answer. Now it's your turn, Mirula. Now this is I solved this question. Okay, because this question for 6 and 7. So he talk about the graphs which show that the spring is
A.
sorry
A.
A. Yes, correct. Now let's move to the last question, Habiba.
I think it's A.
You think it's A? What about you, Mirula?
A.
Yes, A is correct answer. Next time we will complete solving, okay, questions as a practice, okay, and after that we will move to a new thing. If we have finished all of solving of this, we will turn it to the young modulus and the stress and the strain like this. Okay. Any question before leaving? Habiba, do you have any question?
No.
Mirula?
None.
Okay. See you on Wednesday, inshallah. Bye bye.
Thank you, sir.
Thank
Bye.
you.
Welcome.